trapezoids from 0 to pi. These are our table with all of our y values. So first we're going to find delta x. We get pi over 8. Then we're going to use our formula to approximate his travel distance or his area under the curve. So we get t sub 8, because we're using 8 trapezoids, pi divided by 8 times 1/2 times f of 0 plus 2 f of pi over 8, so on, plus f of pi. And we get t sub 8 equals 11.7591 miles. Unfortunately, Mr. Farrar will have to keep on practicing to get up to a bigger speed. Good luck, Mr. Farrar. Example 4. We have to find the area under the curve of root 3 minus x plus x divided by 2. In quadrant 2, you can choose any interval you like, but there has to be 6 trapezoids. Use trapezoidal approximation. So first we're going to choose our interval. But keep in mind, because you can't take the square root of a negative number, we have a restricted domain of 3 to infinity, so that all the y values have to be in quadrant 2. So I've chosen to use the interval of negative 6 to 0, just to keep it simple, but really you can choose any interval you like. So first we have to do find delta x. You get negative 6 minus 0 divided by 6, so very simple and easy. Delta x is 1. We're going to find the y values and plug into our formula. There's our y values found using the graphing calculator. C sub 6 equals 1 times 1/2 times f of negative 6 plus 2 f of negative 5, so on, plus f of 0. T sub 6 equals 5.5258. Alright, now we're going to learn into a little bit of a rule. So example 5. Find the average of the left hand and right hand approximation and trapezoid approximation of 1 divided by root x on the interval 3 to 8 with 4 trapezoids. What is interesting about these answers? So, let's solve it. Find delta x, b minus a over n, 8 minus 3 over 4 equals 5 over 4. Find the left hand, right hand, and trapezoid approximations. The left hand is going to be 2.3422. The right hand is going to be 2.2183. And the trapezoid is going to be 2.2803. And then we're going to get 2.3422 plus 2.2183 divided by 2, the average, which is 2.2803. So, the reason that the trapezoid approximation and the average of the left-hand right approximations are even is because there's a rule. T sub n equals L sub n plus R sub n divided by 2. And you can use this rule when you don't feel like using trapezoids. Example 6. Find the trapezoidal approximation of this table. But there's something a little tricky about this table. As you can see, the delta x's are not all equal. So when you have delta x's that aren't equal, unfortunately you have to calculate each individual trapezoid because you can't just use the uniform formula. So here's all the busy work. We're going to do half of 3 times 11 plus 8, half of 1 times 10, blah, 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 so on, so on. We're going to add up all of these numbers, and we're going to get 35 units square. Mr. Farrar is happy with that answer. Let's carry on. Example 7. Find the area under ln of x cubed plus 8 on the interval 1 to 6 using trapezoids with n equals 6 and n equals 12. So that means we want to use 6 trapezoids first and then 12 trapezoids. These are our two tables found using the graphing calculator. So first we're going to find each delta x. We're going to do 6 minus 1 divided by 6, 5 over 6, that's for the 6 trapezoids. And then we're going to do 6 minus 1 divided by 12, 5 divided by 12, that's for the 12 trapezoids. Calculate the y values and then plug into your formula. So first we're going to t sub 6 equals 16.5502 units squared, and t sub 12 equals 16.4085 units squared. And keep in mind, the more trapezoids you use, the more accurate your answer is going to be. So really, more often than not, we want to use t sub 12 as opposed to t sub 6. Here's some common mistakes. Don't forget to calculate the trapezoids individually when the delta x are not equal, as we saw in our previous example. This is really important because it can really mess up your final answer if you use the same delta x, even if the x values are not evenly spaced apart. Make sure the endpoints are not multiplied by 2, because really they're only used in one trapezoid each. And never forget to divide by 2, because the trapezoid formula is always half of height times base 1 plus base 2. Here's some tips.